Hi everyone, welcome to another Wolfram language design review meeting, part of our incremental language development series, and we seem to have a few topics here today. Extension to nest tree and treefold. I have a feeling there's just a lot more to do with these, but okay. To allow nest tree to take a list or association of operators. Gosh.
Right. So in this first example, you're using regions to calculate the children at the country level, but you're using subdivisions to calculate the children at the division level.
So you're saying, this is saying with different part numbers, use different. I mean, we could imagine the same thing for map, couldn't we?
Yes, like a version of Mapple that takes a list of functions. Yep.
That says at different levels do different things.
Exactly. It's the same concept.
And it's not a supplied type wrapper. I mean, it's not a wrapper of some kind where we're saying, just like we were talking about, things like, map, immediate, evaluate, blah, blah, blah. Map.
So treefold can already take a list of exactly two operators, and this suggestion would allow a list of any length.
Okay, but I mean, one could imagine something like this, where you say, level selected, 1 or 2 goes to F, 3 or anything or something goes to G. Is that crazy? Might not be useful. I don't know.
So you're saying that in these functions in which we map something or we do something at given levels and we have two separate arguments, this will be like a combination of those two arguments.
Yes, I mean, but this is something where you can select. I mean, here, if I'm understanding correctly, this means 0 means the root.
Yes.
Is that right?
Yes.
So I'm not entirely clear on what problem we're trying to solve. So what does a list of two things mean here?
What does a list of 2 mean right now?
So
in next tree, it's meaningless. Like you would just apply the list to the function.
Okay.
Nonsense.
Oh. So what is the thing that takes two? You said something takes a list of exactly.
Treefold does have an option for a list of 2 elements, and that
what does that mean?
It repeats the first one for all of the non-leaves, and it uses the second one for the leaves.
Oh boy.
And so then what would an arbitrary length thing mean? Use that guy at that level?
1, level 2, and so on.
Right. Well, that I mean, that's a complete disaster, right? Because then you have a 2-level tree. Well, I guess maybe that would.
No, you just have to pin it at the end. I mean, what you got to do is okay. There's treefold.
Yeah, look there.
For what it's worth, the thing with nest tree is equivalent to if you do through compose the list.
Right, but my point is that, right, so you have some big tree with, say, 4 levels, and you give it a list of 4 things, and it applies one to each level, and you give it a list of 3 things, and it applies things to the first 3 levels, and I presume ignores the 4th level. I'm not entirely sure.
No, I think what it would have to do, given the existing syntax, is it has to pin 1, 2, 3, 4, and then the last one has to be rest, so to speak.
So the last one is always applied to the leaves, and
exactly.
If the tree is deeper than like let's say you had this 1, 2, 3, 4, but you had something of depth 5, it would repeat the 4th operator. which is consistent with what it's doing now for the case where you have a length 2, because you give an operator for the root and it repeats it for everything except for the leaves.
I see. So if you had a list of lengths 3, it would apply the first one to the root, the second thing to all the intermediate levels that are not the root, and the third thing to the leaves.
Yes.
Okay, so why do we want this in the first place? This thing about having, different levels, because you're saying we're using a tree to represent something where the levels on the tree, and we're going to have the same issue that we have with parts, where in the end, it's going to be like, we really want named parts. That's why we have associations. We don't have trees with symbolic levels, do we?
No, I don't think so.
It's more that you might have different kinds of entities at different levels, and hence different notions of children. Currently, NestTree handles the case well where all of the nodes have the same type, and the child operator is always the same.
Right, but the thing I can imagine is that you want to label the levels in a tree with, country, ADM1, administrative division, ADM2, ADM3, etc. Right? Do we not have a good way to reference level 3 that is named county? So, see what I'm saying?
Yes, it's a separate thing, but yes, that's a good point.
Assuming some sort of rectangularity, yeah.
Right. Well, I mean, we don't have a named levels mechanism for expressions, for general expressions either.
Right.
Yeah.
I mean, I would like to claim that would be a useful thing to think about. And it's something that may be relevant to our new sort of data containers.
If we had such a thing, they could be used in the association as left as keys of that association there.
Yeah, exactly. Right. So there's the question of named levels for expressions, etc. I have no idea. I mean, let's say we have, something like this. How would we even think about a named level play for this? I mean, we would have to have a wrapper around this that says, named levels. I mean, I don't know if any of this makes any sense. And then lots of things would have to support that. Does that make any sense? I mean, again, maybe it's coming with data container, something like this.
Right.
Yeah, I think so.
Sorry, Jose, what did you say?
I think this needs a more powerful container, like data container, not a dedicated object.
Right, because I think that then you're hopelessly lost of like, well, what happens if you have a thing, right? Does the named level, if that's embedded in something bigger, does the named level wrapper magically disappear, and there's no way to get that head out of the.
All right. What is the relationship between data container and trees?
Well, at the moment, what's being worked on with data container is rectangular things, which is not trees.
Boy, is this accurate? I definitely do not know my British royal family genealogy lineage based on this. Okay, never mind.
I think it's a hierarchical character that is common to both. It is that trees are more general.
I'm sorry, a common. Yes, okay.
I think it's only the hierarchical character that is common between trees and deeper arrays.
Right, but okay. So the thing in issue here is, does it make sense to have NestTree support an association syntax with numbered by level number, right?
Yes, or the list. I think actually the list is like more fundamental. And then
Well,
association
except
is
with that weird thing about the leaf anchoring. But the
Is
last
for
parameter really
is for
special.
treefold only, not nest tree.
Yes, but I think the fact that in trees it happens relatively frequently that we want to map different functions at different
Yeah,
levels.
I agree.
And this is the sort of construction which would allow us to prepare something clever to call entity value efficiently.
Yes, I agree. I mean, this seems reasonable. Okay. Do other people have comments about this?
So do we agree with the
All
repeating?
right, I'm not entirely clear what this is. Is this
Okay, so
added?
the proposal is that the first argument of which functions, treefold, nest tree, which other ones?
Just those two.
What about tree map?
Well, tree map takes level specs, right? And including sort of named level specs, right? Not just. So I'm not quite sure how those things would interact.
Right. So this is the discussion we were having before about merging the two arguments, the first and the third.
Yeah.
So it's less natural here. But the idea of mapping at different levels, like map all, is interesting.
Tree map. Okay. Tree map defaults to map all, basically. And this is what levels you're mapping on. And the thing on offer, so to speak, would be a tree map of, 1 arrow F, 2 arrow G.
Mm-hmm.
On the tree, and then the level span would be the third argument.
Perhaps it's a matter of having respective lists. So for example, in this example you were showing, when we have 1 and 2, we could have a list of F and G.
Sure. What's your point?
I'm trying to maintain the current structure of 3 arguments and still generalize it with 1 and 2 in the third argument.
I don't see anything wrong with that. I mean, that's just saying that. Right. I mean, but if
Yeah,
this
actually,
argument here could have a
I
pattern.
think actually the level spec is independent of the function. Like, I think it makes sense to have a list or an association with any level spec. I guess if you use the association and you say levels 1 and 2, but then the level spec is level 3, you're just applying the identity because you didn't specify an operator for that level.
Right. Well, my contention will be this looks reasonable. Anybody else want to comment on this? But by this, I mean the ability in these functions applied to trees functions to segregate what function gets applied based on what level it's on. Objections?
I'm only thinking of the case in which mapping a list might have had a meaning. Is it possible that users
might that be? I mean,
I don't know.
mapping an association does have a meaning, and that's more scary. That could cause trouble.
Mm-hmm.
Right. Mapping an association actually does seem like a real problem because that's pretty common thing to do.
That's a problem, guys.
Mm-hmm.
I mean, it's a little ugly, but it could do a list of rules.
Ugh. I mean, mapping a list, I don't think is worth worrying about.
Yeah, the only time I can think of that is if you're preparing for some crazy thing with through. but I think that's not very common.
Yeah.
We could wrap an association in another layer of list, like have that as a workaround
Blarf.
if you actually want to map the
Blarf.
association.
Blarf. Nobody's going to know that. They're just going to get the wrong answer. How useful would it be to do the non-association form? Just the list, not support the association.
So the list form, you need to list the operators at every level, starting from the root.
Or how do you do it with the association? Do you have a blank on the left-hand side?
Can you use a list of rules instead of an association?
Well, that's what Crystal was saying.
Well, I mean, like here, so you say 1 goes to F, 2 goes to G, but you didn't have to say 0 goes to anything. You can
Right.
just-
And how do you do the 0 in the case of the list?
in the case of a list, you'd have to put something there. It'd have to be like the equivalent.
Well, where's the there?
Like identity, comma F, comma G.
I understand that, but the first element is the 0th element, really?
It is the level 0.
Ugh.
Well, with tree or with map, that would depend on the third argument, right? If the third argument says from 0 to something.
Yeah. Well, that's an interesting claim. I mean, that is shifting where you are referring to with the first element.
Right. And that might be why we need a third argument.
Sure.
For map.
And I had thought that there wouldn't be a shift, that the levels would just refer in both cases to the levels in the original tree.
I think with tree is clearer because you typically map on everything. But if this was ever to make it into map, then we would have to be more careful because map defaults to 1.
Yes. Okay, hold on.
That's a good point.
You know, I really don't like the fact that the association thing is not going to work.
Yeah, I tend to agree with that. No.
So do we do a list of rules then?
I think we should start with a list. I think that's the.
You know, Nick is commenting. What about supplied?
Not sure how that would help.
Well, so I mean, it's a little bit complicated, right? Because you
would be putting like this list in the second argument of supplied.
It will be this basically.
But wouldn't supply be associated with each function rather than with the list of functions?
Oh, yes.
But there's a pure function around the whole thing in this case, isn't there?
I don't understand this pure function.
Yeah, this pure function is.
Yeah, this doesn't work.
Oh, I super don't understand it, actually. Yeah.
No, I mean, the correct version of this would be this very weird.
No, but I think this is doing something very deeply.
No, I agree. The
supplied
should be on the right hand side of each rule. It should be 1 arrow supplied around the F.
Right.
Why?
No, because this case is totally different because this is a pure function. This isn't even the usage where you pass an association in.
No, I know. This is an alternative to passing an association. This is.
I don't think it is. Like, what's the hash level even doing? Like, what? I mean,
that's saying that this has tree map.
This isn't an association of operators. This is just a pure function that like returns an association.
Right.
Oh, I see.
This is structurally completely different.
Yeah, right, because it didn't put the expression in there.
Well,
It's a
just
map.
try for your own sanity. Just write a version of it below where it is what we're talking about.
Okay, what is it?
So you tree map and then write an association. And then I guess 1 arrow, F, 2 arrow G. And maybe, F and G can be pure functions, and you'd put supplied around the F and around the G if you wanted to pass them supplied arguments.
But why does that help? I mean, what we're trying to do is select from the association using the supplied level number.
Supplied what?
Okay, look, remember, supplied in tree map, right? Supplied, just to be clear here, we can have F of hash expression, hash level. Okay. And
I
then
think I'm
supplied.
finally where this is going.
What's that?
I think I finally see where this is going.
Then we have to say supplied here,
Yes.
right? Okay, so now what I think Nick was saying is, why not use this to do the selection?
I'm
I
not
think
sure what you
this
mean
would
by
work.
to do the selection.
No, look. On level 1, this will bind to, that says 1 here on level 1.
Yeah, I see that. It'll bind to 1, and then on level 2, it'll bind to 2. Okay.
Yes. And then these expressions will bind to, because this tree map is going to visit every node of the tree. And at every node of the tree, expression is going to bind to the payload of the node, and level is going to bind to the level number. So I think it would work. I mean, it's kind of stupid and inefficient because it's going to construct everything on the left here.
Maybe you could use rule delayed.
Yes. Yes, perhaps. But I mean, I think this would work.
This is basically using supplied to have one function that behaves differently on different levels, rather than
Yes.
trying specifications for different
Yes.
levels.
Right, although you couldn't, right, if you wanted to distinguish between leaves and not leaves, you couldn't do that unless we managed to supply negative levels or something.
Yeah, which we have the option to do in the supplied specification. I mean, you could also say this could be leaf or not type thing as a value. I think we even had something like that in the supplied mechanism. I admit this is rather complicated, but I'm trying to think. I mean, I just don't think it's going to work to have an association there.
I like the list of operators because it extends what we're already doing with treefold with the pair of operators.
Okay, is it useful enough?
Another motivation is what Ian has in the next section, which is a generalization that includes both directions of going down and then going up. And it's a promising idea. There is too much material here, but I explain very quickly and then Ian can continue. So the idea is to manipulate a tree or an array, going down in analysis steps and then going up. A bit what dataset does already in query language.
Yes.
It's just that rather than having an unpredictable way of knowing whether an operator will be treated going down or going up, this has two lists: the list of going down operators, the list of going up operators. So it's much cleaner, and you can have at the same level something happening when going down and when going up.
When you go back up, has it evaluated?
Yes.
Yes.
Right, so that's the big difference. So in terms of the kind of the execution graph, you see the recursion going down, it reaches the bottom, then it does the evaluation, and then you see the next part of the execution graph, which could be of a completely different expression coming back up. Is that basically the picture?
Yeah, basically you get a result from each branch that you took, and you
But
apply
I
an
think
operator to the list of results.
I think this is evaluating at each step. So at each level that you cross, it will evaluate the function that you have there. So it can potentially modify what you have and continue going down. The same going up.
Wait a minute.
Yeah, these are all starting with the seed value e to the e to the e to the e, and then using different operators to build different trees.
One of those should be, have an echo in it, so we actually see what's being seen at each step.
What can you tell me? What does this mean? This is going down and going back up again. Is that right?
So the second argument. Can you highlight the second argument
This
of
thing here.
expression transform? The if. So that is the going down operator. And then the third argument is a pair of operators.
Oops. Did I get that right, or am I confused here?
After the ampersand.
And now, what's this?
So here we have two ascending operators.
Oops.
Won't you need an echo inside of each operator?
Yeah, I
Or
think so.
What Steven's doing is going to just print the list of operators. I don't know if that's what he
Yeah.
wants.
That's not what I want.
Well, in that case, I think you need the bracket inside the ampersand.
That's what I thought. I was confused by being told otherwise.
Yeah, and I thought you were just trying to print the list of operators. I'm sorry.
Okay, so this goes there. This is a good case actually of where you don't actually know where the bracket is going to go. Actually, we should make sure this case gets fed to the folks who are trying to do bracket completion, because this is not an obvious case. Okay, let's take a little look here. Okay, so we drilled until we got to the none. We logged until we got to the none. Why is there an up to there? And what happens with up to? Up to, we put down an X.
Because you hit the none. So when you
Yeah,
hit
I understand.
when you hit the leaf.
Can we see some other examples of this? Can I see something where we have actual non-trivial operations happening?
Yeah, there's a neat example section and there's a comparison with query section.
so how does it choose between up 2 and up 1?
Up to because it's the descending operator returned none, so that's the last level. So it applies the ascending operator for the last level.
Okay, so this is similar in structure, that the first thing is everything except the last level, and the second is the last level.
It's basically nest tree composed of treefold. Same arguments.
So this type of idea is much used in dataset with group by. And so as you go down, you do group by, and then the dataset is being modified. So adding more levels. And then when you go up, you do aggregation type of operations like total, etc. So this is an idea of allowing you full flexibility of what to do going down and what to do going up.
Is it obvious that you just go down and then come back up again, that you don't bounce around halfway and things?
It could be generalized, yes. I guess this is just the assumption of just going one down, one up.
Well, one of your functions could be another expression transform, right?
Yeah.
Wow.
Okay, so let's just bigger picture here. Okay, so map goes down an expression tree, spraying things into it. Then, okay, then those things might evaluate. Then one thing you could always do is redo the map. You wait for everything to evaluate, you bubble up to the top again, then you go back down in again and evaluate stuff and map again. This is inequivalent because why?
The levels will be different. You'll have new expressions.
Yeah, think of group by again. A new level appears in the middle and shifts all the levels below.
Okay, but
Which means if you were to chain this as a separate operator after the fact, you would then need to know to apply your operators at one deeper level.
oh gosh. Okay, let me try again. So let's see. The reason, I mean, the F could evaluate to a 10 level object. Every F could make a 10 level object.
Right.
And so you're saying that knowing where to apply G, how does it know that? How does it know? Does it apply G to wherever I mean, let's say that it made a 10 level object. Does it apply G 10 times as many times, or does it apply G only at the places where it had made that complete 10 level thing?
The second one that you said. Basically, you're going to have a call stack. Like there's a function that called the function that produced the children. And once it gets its results, you apply G to that.
Okay, to the results.
Yeah.
Okay, and this is useful. Right, it's essentially like a map and reduce operation, isn't it? As you come back up.
Yes. Mm-hmm.
It feels somehow ungeneral.
It's for divide and conquer algorithms.
Okay, where otherwise known as essentially map reduce.
Mm-hmm.
Okay. So, okay. So how does the Sapinski divide and conquer?
So you start out with the three outer points, and the descending operator generates a list of three sets of 3 points for the three smaller triangles.
Yep.
So that's your map or your
Okay.
your nest operation.
And then on the way back up. Okay, so that at the end, when it's gotten to the bottom, it's made a bunch of points, basically.
Mm-hmm.
So for example, if I said, just to understand what this does, if I said map all, I don't know, why did that do that? Oh, because the arguments are in a different order. Funky
Okay, what
squirrel.
is the structure? Okay, I'm sorry, I'm playing with my own examples here. What are the arguments what are these functions supposed to return?
What is this? What is this? What is this?
Get rid
What
of the
is,
three.
Which three?
That the third argument there's no third argument to map all.
Right. Map all doesn't need a level spec. It has an implicit level spec.
Map all has
Okay.
an expression already. This is building an implicit expression that never gets evaluated except for the explicit ascending operators that you give it.
Okay, so if I replace this with an F to prevent this from blowing up. Okay. So what will that be? That will be not quite resolved because it didn't quite. But in the other case, the reason it blew up was because I'm confused. Why didn't I have at the end of that other thing? Oh, because I couldn't, by the time it was in the structure of the list, it was not going to evaluate properly. I'm a little confused. Can you explain to me what was going on before?
I'm not sure. Like, so circle points of 3 is a matrix.
Yeah,
You're mapping
I
over a
understand.
matrix. I don't.
So
There's
it's a
some
question of what exactly you're mapping onto. Okay, but I understand what this is doing.
This is coming from threading. I'm not sure how this ends up getting so deeply nested.
Because I'm not sure. I think its level specs are wrong. All right. Look, I think this idea though, okay, you go down, you spray functions on things. You come back up.
Also
you were
spray.
taking, I know, but on every place you come back up to, okay, let me try and explain it this way. There's an anchor point, which is the sub-expression whose head is the thing you applied with map. As you come back up, you get up through a bunch of those anchor points. Because the Fs that you put there are still there. They may have innards that, you don't get back to the level where the F is until you have recursed back to that level.
Yeah, and to clarify, one difference between expression transform and query, well, so query like compiles things to maps and things and basically sprinkles operators. Expression transform is in the nest and the fold family where the operators immediately evaluate. So it's not like building an expression and then evaluating it. It applies and evaluates the operator.
I understand, but isn't that an implementation issue, not something else?
I don't think so, right? I mean, whether, right?
It's the difference between generating new structure or just mapping over structure that you have. Sorry to cut you off, Itai.
Yeah, but right. Right. Well, for one thing, if you do things iteratively, you have some control over evaluation. Whereas if you sort of replace everything and then just let things evaluate, you're at the mercy of the evaluator. Right. Those are going to get you to two very different states.
Yes.
Yeah, for example, I use this internally in expression tree to prevent evaluation.
Okay, but basically, okay, it was going to go down to a certain specified level. then it's going to come back up again. As it comes up, it is applying a different function. As it comes back up, the normal map would apply identity as it comes back up, right?
Yes.
I'd say it's more the other way, that the descending operator's identity and on it, and the operator that it's mapping is all the way back up. But I guess I don't know the actual.
Why? Why is it that way? I don't understand that. I mean, you
Usually
sprayed F.
bottom up depth first traversals.
Okay, let's look here.
I think it doesn't matter in this case, given that they are all going to be inserted before evaluation in map.
Exactly.
All.
Okay, so that's sprayed Fs everywhere. So now let's imagine that our F is actually something that doubles the depth here. So let's say that the F is instead U of V of hash.
Right, and so the depth is coming from the point when you let this evaluate. But say if you had hold of, like, if the second argument of map all was had hold, that wouldn't happen. Whereas expression transform can eat things with head hold just fine.
Well, but the basic point is that every U of V of something is an anchored object. We know where it is. You can pick up that sub-expression.
Yes, but in expression transform, the new operators would act on the results. So they would act on the U heads, the V heads, rather than the original.
No, I know, but they're acting on the whole U of V of D. They don't act individually. The thing gulps. The ascending function gulps these whole objects, doesn't it? I think it has to.
Yes, the ascending, yes. I was thinking on the descending.
The descending we just did here.
Mm-hmm.
So I think ascending takes whatever was written by the descending thing. It takes whatever sub-expressions were written by the descender and applies the ascender to them after their innards have been evaluated.
Right.
Yeah.
To the results of wrapping the descending function.
Not just wrapping, but evaluating the descending function.
Yeah, right. Wrapping the descending function and yes, and evaluating it.
Mm-hmm.
But the whole point is it hasn't, each one of these is a sub-expression where it can pick it up. It knows what the sub-expression is. That's the surprising thing. Because normally when you do evaluation, everything's going to change. But because this thing spawned an evaluation, basically it's applied to the ascending function is applied. Another way to put it is applied to the results of evaluation of the expression that the descending function spawned. Does that make sense?
Yes.
And it's because it always knows what it spawned. It's never confused about where it is when it spawned that thing. Even though the structure can have changed completely, the ascending function knows where it is because its corresponding descender. So another way to put it is, okay, there are pairs. Descend, ascend. that are applied to particular sub-expressions. One on the way down, one on the way up, right? In other words,
Yep.
we can pick the sub-expressions. Like for example, in this case here, we picked the sub-expressions. Boom, it's been applied to those. Now, we can think of stage 2, which is for each of those Fs, first replace with the descender. Okay, so here's a way we could do this. If we said this, f of x blank goes to, I don't know what, x plus 1.
Do you mean arrow?
I certainly do. I see, it doesn't subdo it. Okay, but the thing I was trying to do was I replace it with something so long as it comes up from the bottom. And then whatever I replace it with, I then, oh boy, this is confusing.
So I just pasted something into Zoom chat, which is helpful to me. So, right, I basically took the example, the first example, only I replaced e to the e with hold of 1 plus 1 to the 1 plus 1. Right, so the first thing applied to the whole expression, right? Then it applied at the first level, which evaluated to 1 and produced a log of 4. And then at the next step, it didn't see any of the 1s or 2s that were originally there. It applied it to the result of the previous step. So I found this
Right.
helpful in understanding how the evaluation is happening.
Right. Okay, let's go through this again. As you're saying, there is one thing that it does is spray stuff on the way down. Then it aggregates on the way, or it can aggregate on the way up. I'm not really understanding.
More that there is no down until you apply a descending operator. The descending operator defines the expression that you're going to traverse down, and it need not be the one that you started with.
As this example here shows.
You know, the expression you start with could be the number 1, and the descending operator returns a pair of numbers.
Oh boy. I think I'm more or less understanding this. I don't think I quite have it in a clear way.
Right. What's not, I guess it decides to stop when it encounters a none. It's not entirely clear to me when it
That
stops.
doesn't seem right.
When it
seems like
returns an atomic expression or a zero length expression.
yeah, which is the same way that map all terminates.
Okay.
I mean, it could also be given a level spec, that it would bounce from that level spec.
It does. Here it's saying infinity. You could say 3 instead of infinity.
So let's do a slightly more realistic example. Okay. So I claim.
And 3 really means 3 steps or 3 down steps, right? Because those levels may have nothing to do with the levels of the input expression.
Mm-hmm.
Okay, where's the data? Oops. The data somewhat peculiarly comes first. Okay, so let's do Okay, now my idea was on the way down, I want to add 1, add to 2x plus 1. Okay, on the way up,
I would suggest to add a head. Wrap the 2 hash plus 1 in H or something like that, so that we see where it's placed.
Okay, hold on, I've got a different idea. One second. Oh boy. Okay. Who understands this? The down is showing me the output, right?
Yes.
Yes.
So down actually returns an array of the same depth as it's what it's given.
Okay. Maybe we should be echoing the thing that was given. Actually, we should probably echo both. Can we do echo evaluation, or will that confuse things totally?
I would just put echo around the slot,
All right.
echo label.
Well, let's just do an echo because we've got to know where it's going to be.
Well, those are going to be actually the same thing, yeah.
Okay, so this is a down. It got to the bottom, started recursing back up.
No. Where your cursor is? Or do you
It's
mean
at the top? You mean? Yeah, you're saying this is at the top.
Yeah, this is one
right, and it evaluated, right? It did 2 of that plus 1, as we can clearly see, or just
Yeah, okay.
Yep.
So that was 0.
Right, and then it took that, used that, or I guess it went to, where is that next input coming? Oh no, that
it
wait,
goes one level deeper and it finds the first matrix, the 3579, and then it applies there the down operator.
Oh, okay.
then
Oh, there's an extra set of braces there I didn't see. Okay, yeah.
Okay. Oh my God.
And there, so you see 23, when you applied down to 23, it gave 47. So that's how it knew to stop, because 47 is a raw expression. So that means 23 is the last result.
Yes. And now it comes back up.
In your up, can you change slot to slot 2?
Which?
Echo at slot should be slot 2.
Here?
Yes.
What the hell is slot 2?
The
The
first
result.
argument is the original sub-expression. The second is after it's transformed by down, I think, right?
Yes. The first argument is the payload.
Maybe we want to echo both of them.
Right. So look at the 23 down gives 47. So 23 is a leaf.
Let me just understand the whole result for a second. Just understand what the whole result.
And does down have both a #1 and #2, or only up?
Only up.
Okay.
And only for the non-leaves. The non-leaves is just a single argument. The leaves is a single argument.
Okay, so it doesn't do the most obvious thing.
Well, because it's applying the operator multiple times as it goes down.
I see.
Right. So, and then when you say original, does that mean like referring to parts in the original input expression, or like what
can you do comma H after infinity?
What does that do?
So H is applied to the same expression that the down is applied to, and it gives a payload. So the down is applied to an expression and gives the children. The H is applied to an expression and gives its payload. And both of those things are
so we're seeing those, right? Right. So because you added the H, right? That, and we're seeing the H in the up labels there because we're echoing #2 rather than #1. Yes.
Yes.
Right. But I still don't understand what exactly where exactly #2 comes from. Is it like the last thing before this thing, the last down was applied to it?
Well, so you apply a down and you get some expression,
Mhm.
and then you replace every sub-expression at level 1 of that result with the result of recursively doing expression transform to it. That result expression is #2. It's the result of down after you have recursively applied expression transform to each of its subparts.
It's the result of.
Is Christopher following this?
This seems pretty confusing.
Yeah, it's still not entirely clear to me what #1 and #2 are. Yeah, so #1 is right, and like when I go to right, so like if I'm at the next to last line, well, actually, Stephen, can you change that echo at #2 to echo at list #1, #2, comma #2, just so
Yeah,
we
but then
can.
it's going to give completely different result. It's not. You don't want the.
Oh,
echo.
right.
What do you want it to return? We can just echo something and then return something.
We
different.
use
Well,
#1 as the label for the echo, like the 2-argument form of echo.
Oh, yeah.
So
what do you
#2
want
is
to do?
the thing you want to return, and then use #1 as the label as the second argument.
Like that.
Yeah.
Thank God.
Right. 711. You see the H of 711?
Mm-hmm.
That corresponds to the 711 that you see above. Right?
Okay.
To which down had given 15, 23. The result of recursively transforming 15 and 23 is given by the list H of 15, H of 23.
Okay, so let me rephrase this in my own words. So when we hit an atom, or I guess a length of list, or an expression of length 0, we just get the result and we're done. Is the up even applied to it? Because I don't see any 47s here. Maybe I'm not looking in the right place.
Only if you do a list. Only if you do a list in the third argument of expression transform. By default, identity is applied to the atoms.
Right, and then
although they need not be atomic expressions, they're just the last thing.
Right, and then so for each, I guess, output, from down, we pair it up with the input that produced it, and we wrap those in H, and then we apply our function.
Yes.
Okay. And that's what's going to ultimately be, and the result of that function is going to be what ultimately ends up in the result.
Yes.
Okay.
I'm fairly confused. I mean, the big picture, we still think it's map reduce, basically. It goes down, it sprays functions in. It comes back up, it is progressively aggregating. As it goes down, it's progressively applying functions to smaller and smaller subparts. Right? I mean, let me just understand something here.
Right, and I guess it really is important to talk about these as steps rather than levels, because right, there are no lists in that final result because it sort of, I guess, bubbled up and gathered them together with H and our total. Oh, there's a total there, so total will flatten it no matter what. Okay, so I don't.
Sorry.
Yeah, so I'm not sure if there will be levels or not. I guess I was confused by the total.
So I would say the one difference between this and both MapReduce and Query is that in like MapReduce and Query, the descending operators are like filtering and sorting an expression that you have. Here, the descending operators, you know, it's the difference between structural recursion and generative recursion. If the descending operator can return an expression with new sub-expressions and you recurse through that. Which I don't think MapReduce does, and Query does not do.
Okay, let me just understand. Map all goes first down to the leaves and then it comes back up again. Right? That's what we're seeing here.
Well, I mean, no, what we're seeing is, right, map all sticks everything in at all levels and then normal evaluation occurs. So since there's nothing with a held attribute in here, then leaves get evaluated prior to the expression, right? It's heads, then leaves, then the down values is the standard order of evaluation.
I see. So you're claiming the echo doesn't fire because it didn't fire on the way down inside map, because map was just constructing a structural thing.
Correct. And in particular, if you put a hold at in front of, say, the 3-4, then you won't get any prints from any echoes from there. You'll see the literal echo inside of.
Oh my God, what's that? What the hell is that? Well,
it went inside everywhere. At every node, it inserted the function, but once you're inside the hold, it's not allowed to evaluate, so you get ever more compound heads.
Oh gosh. Okay. Okay, so the way I should think about it, even though I do think a map all is going up from the bottom, that's only because of the evaluation thing, but it is going down from the top. But again, the evaluation...
It's structurally recursing through an expression.
Right. I mean, so since I happen to know what the C code is like, right, it basically goes down each level and sticks things in until there are no more levels to stick things into. But right, that's irrelevant. The evaluate, right, it never allows the evaluator to fire. Of course, unless there's an association in there, as we discussed earlier today.
Yeah. Yeah.
I think that
once we have immediate evaluate, then it'll be more interesting to see what examples like this do.
I think the way to think of this is that map all is insert all and then evaluate all, while ExpressionTransform
Yes.
inserts and evaluates at each level. And each level means the levels we have right now, which might be different from the other ones because the previous evaluation changed the levels.
What previous evaluation?
So you insert and evaluate at the first level. That changes the whole expression below, but the new expression has levels too. So now you go to the second level of the new expression and insert and evaluate.
Really? No.
Yes.
How can that work? I mean,
No, so I think it's the difference between structural and generating. So it's not that you start with an expression and that you go through the levels of that expression. It's that you start with a seed value and you're creating an expression with levels. But that's just a seed value. You care nothing about the structure of that expression. The structure that you care about is purely the structure defined by whatever these descending operators return.
So then is the claim that what this expression transform is doing is that at step n, it applies the function to only to the expressions at level n of whatever the last generated thing was?
No, it's always at level 1 of the previous generated thing.
Okay. In which is why I go back to saying it's not useful to talk about levels. We should be talking about steps.
Right. The comparison with levels only makes sense with trees because
Okay.
it's not the levels of the expressions.
We're not going to solve this
level.
today. Let's understand what we're trying to do here. For many years, we've had the ascending descending operator concept in dataset. I have never been happy with the idea, with its generality or not. This is an attempt to modularize and generalize that functionality. Fair statement?
Yes, I think so.
Yeah.
Here you know whether a given operator is ascending or descending.
As opposed to reading the novel at the top of the dataset ref page and trying to define what will happen.
Right.
And query can only do filtering and sorting operators, not generating operators.
What's an example of a generating operator?
Do expression transform.
Yeah.
First argument 1. Second argument, do list of 2 slot, comma 2 slot plus 1. Ampersand.
This is so horrifying.
Comma G, comma 3.
Comma what?
Comma G, comma 3. Yep.
Can't even imagine what this is going to do.
This is the whole point. Is it's generated a tree and folded it. If you like, the thing that you're traversing is the 1.
If we do tree of percent, will we see a nice tree?
Do tree instead of G. Literally do expression transform with tree instead of G. This is basically how nest tree is implemented.
Okay, yeah. This makes sense.
This is the thing I'm claiming query cannot do. This is not sorting or filtering the 1. It's generating new subterms.
On the way down or on the way up?
On the way down. The way down is defined by that pure function.
Okay. And on the way up,
And
it's wrapping these in tree. So eventually it wraps these in the root in tree and we get a tree out.
Yep.
Right.
That's a nice
right.
minimal example. Let's go ahead.
as this goes down, it's finding levels that were not there at the beginning, because we didn't have 3 levels in the one. But as this goes down and generates new levels, things get applied to the new level.
Yeah. All right, this is beginning to make a bit more sense. It goes down, it makes an expression.
Or changes the existing one.
Iteratively in this case. I mean, it just, every subpart is being, split here.
Mhm.
And that's why the ascending operator takes 2 arguments, the original expression. That way that you have a payload and a children.
All right, we're getting there, but we ran out of time. So to be continued another time. And the more clear examples you can get, the better, with some echoes and some trees and so on.
Yep.
But I think this is, look, I have to say, this is one of these things. I'm remembering all the different functional programming constructs that we came up with. I mean, there was a time when even fold was hard to understand, which it isn't anymore. And we'll get this one. This one will become easy. Just isn't yet, at least for me. And then, we already know from dataset that this is a useful kind of operation.
Indeed.
All right, so for another time. All right, thanks a lot to people here and people on live stream. See you all soon.
Bye.
Bye.